Hello everyone, very good evening. Today we are going to start the second chapter of our chemistry and which is the structure of atom. So first we have to understand what is atom is. Okay, and then we will discuss about the structure. This chapter is very important because here we are going to discuss about, okay, first we will discuss about what is atom is. So introduction part. Okay, then we will discuss about the subatomic particles, subatomic particles, okay, and their discoveries also. Like we have three subatomic particles called proton, neutron, and electron. We will discuss about them in detail. Okay, with their discoveries, how they have been discovered. Okay, then we will discuss about the characteristics of characteristics characteristics of the matter. Okay, then classification of in classification of atom we are going to discuss about like metal, non-metal, and metallite. We already studied in last year only in your previous standard, is it or not, in detail, what are metal, non-metal, and metallite, right everyone?
Yes,
Yes.
sir.
Yes, sir.
Yeah, so we will discuss about classification of atoms, or see, we are discussing here atom, that's why I'm writing here atom, otherwise we can say elements also. After that we will discuss about different theories given by different scientists, like we have J.J. Thomson's theory, then we have Rutherford's theory, and last but not the least we have Bohr's atomic model. Bohr's atomic model. Okay, so we will discuss about these in detail. Then we will understand about the quantum mechanics, quantum theory. Quantum theory. Okay, so here we will discuss about four quantum number. Number one, we have principal quantum number. Second, we have azimuthal quantum number. Then we have third one, spin quantum number. And last but not the least, we have magnetic quantum number. Magnetic quantum number. So we have four types of like a quantum in our quantum theory in our syllabus. Okay, so we have a quantum number called principal, azimuthal, spin, and magnetic. Okay, then we will discuss about electromagnetic radiation related to the quantum theory, which is given by the Planck's. So we can say here the Planck's quantum theory. Planck's quantum theory. We will discuss about that, and then we will discuss about the spectrum produces the spectrum theory. It is called a spectrum theory. Spectrum theory of atom. Okay, here we have like many series given by the Balman, Lehman series, etc. Okay, then after that we are going to discuss about the de Broglie's principle. De Broglie principle. Okay, and Heisenberg theory. Heisenberg theory. Okay, then next point in this chapter we will discuss about the quantum numbers. Then we already discussed that. Okay, like in atom we used to write electronic configuration on the basis of Aufbau principle. Aufbau principle. Okay, then we have Pauli's exclusion theory. Pauli's exclusion theory. Exclusion theory and Hund's rule. Hund's rule. And on these three theories, we are going to discuss about the electronic configuration that we already did, but I will explain one more time. Okay, because whenever we are going to write the electronic configuration, we have to follow all these like Aufbau principle, Pauli's exclusion theory, and Hund's rule. Okay, everyone. And on that basis, by using all these three, we are going to write electronic configuration. Okay, and this is done. Only we have to understand here the theories given by Aufbau, Pauli's, and Hund's. So this is nothing but the content of this chapter. Okay, everyone. In this chapter, we are going to cover all this point. So I want you have to just take a screenshot, and whenever I'll ask what we are going to discuss next, so just please do remind me because I'm going to erase it after the class. Okay, everyone.
Okay, sir. Okay.
Yeah. So just take a screenshot, beta. Done.
Yes, sir.
Yes, sir.
Okay. So now we are going to start the introduction of the chapter. So we will start from the definition of atom. So atom. Okay, what is atom is? Any idea? I want Aditi is going to answer that. Aditi, I want answer from you, beta. What is atom?
Sir, the smallest particle of matter.
Okay. Sadap,
Sir, it is well, although we cannot say the definition now, it's the smallest indivisible particle or indivisible
yes.
particle which can
Yes.
exist on its own.
Yeah. See,
Although now we know that there's different subatomic
subatomic
particles inside
also.
of it.
Yeah, it is according to the modern theory, but when atom was discovered that particular time,
Yes.
by like many philosophers were there, one of the Greek philosopher and Indian philosopher. Okay, so we'll discuss from that only. See, about 600 BC. You know what is 600 BC means? It is
Yes, sir, before
600 year
Christ.
before the Christ. And before the Christ, okay, it is that particular time when the God of Christians called Jesus Christ born. Before that 600 year, before that particular time, again we have to go 600 year back. That particular time, one of the Indian saint and philosopher you know the name of that?
Is it Aristotle?
No.
Oh
Is
wait,
Aristotle?
sorry, it was Indian, right? No.
Yeah, Indian saint.
I was thinking the other one, the Greek one.
No. No idea. Anyone?
Sir, I know him, I just forgot.
Yes. Last year I taught you that. Rishi Kanath.
Yes.
Rishi Kanath. Okay. Rishi Kanath was the first. Okay, about 600 BC. He was explained about the atom. So what he did basically, he performed the experiment on different matter he found around him, and he broke them again and again into the simpler form. Okay, suppose here we have the one like matter. He broke that into two part, again into two part. Okay, and he performed the same activity again and again on the different matter, and all the time he found that, okay, and he reached that particular situation, he cannot be divided further. He tried to divide again and many times, but one time came he could not divide that particular particle again. Okay, and he named that particle as Parmanu. He named that particle as Parmanu. Understood, everyone? And as he was a philosopher, so he gave definition for that Parmanu also. Okay. So according to the Rishikanath, the smallest particle of universe that cannot be divided further, that cannot be divided further, okay, is called as atom. Is called as atom. Understood, everyone?
Yes, sir.
Okay. So after that, many scientists came. Again, like 400 BC, one of the Greek philosopher also came into existence, and he described the atom. Okay, and he gave the name as atom beta, because atom is the word which is derived from the Greek word or Latin word called atomio. It is atomio. Okay, atomio means indivisible or uncuttable. Uncuttable, or you can say indivisible, means which cannot be divided further, right? So many like scientists came and they work on that particular word called atom, okay, on that particular particle, the smallest one, which cannot be divided further, and they wrote their philosophy regarding that. And he also mentioned that whatever the matter we have around us, so all the matter around us is formed by such a tiny particle, tiny particles called atom. Okay, and one more thing, different matters are made up of different type of particle. Someone is in meeting room, wait a second. Yeah, okay, and different types of different matters are formed by different types of atom. Different types of atom.
Sir, good evening.
Very good evening, sir.
Good evening, students.
Good evening, sir.
Okay, so that time, like modern science was not there, modern instruments were not there that particular time, but still scientists had worked a lot on the structure of atom and their subatomic particles. Okay, but now we have like many things, like we have cathode ray discharge tube, we have electron microscope, we have microscope also, by which we can like go through in the deep structure or deep study also, right? So on that basis we are going to discuss like subatomic particles. Now like we have already gone through, okay, in previous standard, but we have to discuss in detail. So see, till here atom was considered as indivisible particle, but atom is also formed by different type of subatomic particles. Now we are going to discuss that. So now have you took the screenshot, everyone, for that?
Yes.
Okay.
Yes,
Excuse
ma'am.
me, sir.
Ha, beta.
Sir, I just have a small doubt. The two postulates that you gave, all matter around us is formed, and the second point, different matters. Were these two postulates given by the Indian and Greek philosophers previously?
See, these are again mentioned the same thing they discuss again and again, but these points are common, beta. These postulates given by them are common It is also used in like theory given by Dalton also. Okay, so these points were common. Okay, that Greek philosopher about 400 BC, he has given the same point also. So these points were common. Okay.
Okay, sir. Thank you.
Yeah. Okay. So I am just moving ahead here. Okay, so now we are going to discuss about the subatomic particles. Subatomic particles. Subatomic particles. See, when many experiment performed in order to understand whether the atoms do contain different types of particles or not. So many experiments were there. Few of them are like cathode ray discharge tube. Okay, cathode ray discharge tube. Then we have scattering of alpha particles. We will discuss later on all these experiment also, but here I am only using their name. Okay, so on the basis of those principles, scientists came to know that there are three subatomic particles present. Okay, so number one is named as proton. Number second was named as neutron. We will discuss about their discoveries. Okay, so next we have neutron. Okay, and last but not the least, we have electron. Okay, so now we have three type of subatomic particles. So proton is like positively charged particle. So we used to represent P positive. So what is proton? It is the positively charged particle. Positively charged particle. Later on, we will discuss one by one with their discovery also. Who discovered proton, neutron, and electron? Okay, and we are just discussing a little bit here. So protons are positively charged particle. Charged particle present at the center of atom. At the center of atom called nucleus. Called nucleus. Okay, next we have neutron. So neutron have no charge beta, so that's why we used to represent n0. Okay, n0. Zero is what? For what? There is no charge on it. So neutron is a neutral particle. Neutron are the neutral particle. Neutral means there is no charge, no positive, no negative. Neutral particles of atom present. They are also present along with proton also at the center of nucleus. Present at the center of atom called nucleus. And one more thing, see, proton and neutrons are present at the center of atom called nucleus, hence they are also named as nucleons. Shadab.
Yes.
Yeah, that day we discussed about nucleons, no?
Yes.
Because they present at the center
There are
of
also
atom.
other sub.
Yeah, and last but not the least, we have electrons. So electrons are negatively charged particles and they are represented as E negative. So electrons are negatively charged particles. Negatively charged particles. Okay, and they revolve around the nucleus and they revolve around the nucleus in a continuous path beta, in a continuous path. continuous path called orbit or shell, called orbit or shell. Okay, understood everyone?
Yes, sir.
Okay, now very important thing I'm going to write here. See, the charge on one proton, see, proton is positively charged and electrons are negatively charged. So they must be charged particle. So the charge on one electron. Who knows the charge on one electron?
1.6 into 10 power
Yeah,
minus 19.
it is 673. Okay, after decimal you can use 1 also, like 1.6. It is 1.673 into 10 to the power minus 19 of Coulomb. Coulomb is the unit of charge. Proton also contains same charge, but their magnitude is different. Their magnitude is different. So charge on one proton.
You could consider electron to be minus 1.6 and then proton to be plus
Yes. Yeah. So it is the charge is the same. It is 1.673 into 10 to the power minus 19 of Coulomb, but their magnitude is different. Means electron having negatively charged and proton is having positively charged. Okay. So in every atom, number of proton and electrons are equal in number. They always present in equal number. Hence, atoms are electrically neutral. Okay, so very important point, the third one. Every atom, or yes, every atom contain equal number of protons and electrons. Therefore, hence they cancels charge of each other. Therefore, or due to which atoms are electrically neutral. Atoms are electrically neutral. Understood everyone? Suppose
Yes.
we are going to discuss one example here. Suppose we have sodium. And sodium have atomic number 11. That means sodium have 11 protons and 11 electrons also. 11 proton, that means 11 positive charge, and 11 electron means 11 negative charge. Is it?
Yes, sir.
So see, numbers are same, only magnitudes are different, so they will cancel each other. So total resultant charge will be 0, right? That's
Yes,
why
sir.
atoms are electrically neutral. So I want again you have to take a screenshot. We are going to move
Sure.
further then. Ha beta?
How come sodium has 11 protons and 11 electrons, but 12?
Yeah, see, in nucleus, number of neutron may varies beta. It varies. Okay.
And that depends on?
That do not depends on anything. It depends on, suppose we have isotopic form of carbon. Okay, suppose I'm taking example here of carbon. Let me change the color. Okay, suppose we have carbon. So carbon have 6 isotopes, no? Like 6, carbon 6 have atomic mass 12.
3 iso.
Another we have atomic number is 6, but atomic mass is 13 and carbon 14. Right? So see here, if we will compare, number of electron and proton will be the same on all the 3 cases, but in carbon 12 here we have 6 neutron, here we have 7 neutron, and here we have 8 neutron. So they are like naturally occurring isotopes. Okay, they do contain different number of, so number of neutron in an atom is not fixed. If it is varies, that's why we have different isotopic form.
All right, got it.
Yeah. Okay, so in it varies atom to atom. They may contain equal number of protons. And one more thing, in modern periodic table, it is based on like atomic number, but before that it was considered as the, like it was arranged on the basis of increasing order of atomic masses, like Dobiner did, then Mendeleev's, not Mendeleev's, before that Newland did, then Mendeleev's also did. The same way they arrange element in increasing order of their atomic masses, but they didn't place these three isotopes at different places, right? Because they are having similar property, only the difference is the atomic mass. That's why atomic mass is not fundamental property to classify the element. Okay, and it has been proven by the Henry Moseley in
Yes, sir, got it.
1913. Yeah, so atomic number is the fundamental like property in order to classify the element. Okay, so I want everyone have to take a screenshot for that. Done,
Done, sir.
everyone?
Yes.
Done, sir.
Okay, any like question you have? Now we are going to discuss about the discovery of electron. Important. See, the discovery was brought by the Michael Faraday. Michael.
Sir, how come many
Michael
people
Faraday.
say it's Thomson?
They just gave the atomic model only. Okay, like at the center mass is present. Sometime like different scientists they came and they gave different philosophy about the atomic structure. Some like scientists says its structure is like the watermelon structure. Okay, like all the positive particles is spread all over the atom and negative particles are being embedded. So different scientists they came and gave different we can say the
Sir,
philosophy
even for
according
protons,
to
some people say
describe the
it's
structure of atom.
some people say it's Rutherford, some say it's Goldstein. Who is it?
No, not like that. See, they confirm that there is a presence of electron, but it is confirmed by other scientists like this.
Okay.
Okay, suppose
Yes,
suppose positive charge is being discovered in an atom. So, but atoms are electrically neutral. That means there must be negative charge particles are present, right?
yes, yes.
So they just predicted there is a presence of negatively charged particle also, but it is confirmed by other scientists. So here we can say the contribution of both we can say. Okay.
Okay.
Okay. So first we are going to discuss the discovery of electron. So Michael Faraday has started the research on electron. Okay, in 1930. Sorry, in 1830. 1830, not 1901. It is 1830. Okay, he came with one like electrode. We can say electrolytic cell. Have you heard electrolytic cell? Electrolytic cell is like this. Here we have the electrolytic tank. Here we have two different electrode. One is positively charged and other is negatively charged. And these are dipped in the solution having ions there. Okay, it is also called as electrolytic solution. Electrolytic solution. Okay, and here we have like external source of electricity. So I'm using battery here. Okay, so Michael Faraday shows that if electricity is passes through the solution, okay, that solution is having ions, so it is called as electrolytic solution. Okay, solution, then electrolytic process takes place there. Electrolytic process means what? See, suppose this is the positively charged electrode, so it is called as beta anode. Okay, and this is that electrode is connected with the negative terminal of the battery, hence it is called as cathode. Okay, everyone, cathode, anode. Okay, so see here at anode and cathode, on anode oxidation reaction takes place. Oxidation means what? Loss of electron, means loss of electron, right everyone? And on cathode, reduction reaction takes place. Reduction reaction takes place, and reduction means what? Gain of electron. Gain of electron. So see here, loss and gain of electron takes place here, and during this process oxidation and reduction reaction takes place, and it requires the electrical energy. It requires electrical energy. Is it or not? Is it, everyone?
Yes.
So here it is proven that there are negatively charged particles which are responsible for carrying charge from one part or one place to other place. Hence, they predicted that there are like charged particles which are responsible for carrying charges. And see, if anode is here, so here negatively particles are going to attract. So these negatively charged particles are considered as electron, which are responsible for carrying charges from one place to other. Okay, which is result in nothing but the deposition of matter, or maybe liberation of gases takes place. Suppose if we are taking sodium chloride solution here, suppose we are taking an electrolyte solution of NaCl. So sodium, which is positively charged particle here, so it is going to deposited at cathode, right? So it is going to form like deposit, and that chlorine will liberated in the form of chlorine gas here. Is it or not? This is the electrolytic process. Yeah. So he formulated that Michael Faraday, there are some particles which are responsible for carrying charges from one place to another. They are like negatively charged particles. Okay. Hence, he was just predicted negatively charged particles are present in an matter and which or in atom which are responsible for carrying charge from one place to other place. So here it was it was only predicted that by Michael Faraday, it was not confirmed. Okay, but in 1950s many again scientists came into existence, and they performed many experiments, and they performed the evacuated discharge tube, which is also called as cathode ray discharge tube. Okay, so I'm just going to draw here the cathode ray discharge tube. Okay, so in 1850s, not 1950s, sorry, again it is 1850s. Okay, in 1850s, again Michael Faraday was performed this experiment as called cathode ray discharge tube. Cathode ray discharge tube. Discharge tube. See, cathode ray discharge tube means what? Suppose here we have one tube. Here it is like not perfectly vacuum, but most of the gases from that particular tube is being removed out. So here pressure is very low beta. It's really very low pressure is present there. It is almost vacuum, you can say. Only few particles of air are present, and it is being sealed after removing the gas from here. And here like uh, cathode and anode okay fitted, and they are connected with external source of electricity with high voltage. Very important, no? With high voltage. Like this. Okay, and here the vacuum like pump is there in order to remove the gas from here. Okay, and here it is connected with positively charged, so it is nothing but the anode, and that electrode is connected with negative terminal of the battery, so it is called as cathode. Understand? And here we have high voltage of current supplying here, high voltage. Okay, high voltage of current is going to supply from here. Okay, everyone.
Okay, sir.
Okay. So after some time, what happens? Okay, when we used to like start the circuit, so current is going to flow here. Is it?
Yeah.
Yeah. So when current is going to flow, and here we have only like few particles here. So see, it is anode, so it is positively charged. So here more positive charge is going to form here, and this is the negatively like cathode is negatively charged electrode. So here more negative charge is going to form. Okay. So see here, due to like opposite poles or opposite charge formed inside the evacuated tube, or you can say that cathode ray discharge tube, one ray which started like, see, particles are they getting charged here, particles are they getting charged, and they are traveling toward the opposite electrode in order to get discharge. Okay, the electrical discharge through the gases could not be like like possible, but it is possible only at very. Okay, wait a second. Wait, my like laptop battery is about to die. Wait.
All right.
Oh. Everyone, we already passed an hour, beta,
Yes,
and
sir.
it will take like more time, 15 to 20 minutes. It will take again.